Hi everyone, and welcome to Backer Breaks It Down. In this episode, we look at CPCTC and circles and proofs. Remember, CPCTC stands for corresponding parts. Congruent triangles are congruent. So that means we are going to prove that two triangles are congruent, and then we're going to have one additional step where we use CPCTC. And in today's proof, we're going to see how circles are involved. So as you know, a circle is named by its center. So this circle over here, I could call it circle P like this. This is the notation that we use, okay? So in a proof, if you are given a circle, okay, we're going to use this theorem that says that all radii of a circle are congruent. So in circle P, that means that PA, PB, and PC, those three segments would all be congruent to each other because all radii of a circle are congruent. So let's see this in action in a proof. So remember, when we are proving two triangles to be congruent, and even though here it says prove angle G is congruent to angle H, I do need congruent triangles. Okay, so I always start with the given information. If it's a congruence given, I write it down and then I mark my diagram. So we know that GJ is congruent to HJ. When I mark my diagram, I notice that those are indeed sides of my two triangles. I go into my next given. It says given circle centered at O, so I write that down. And I want to draw a conclusion. So what conclusion can we make? Yeah, we could say that GO is congruent to HO. And some of you might be wondering, can we also say it's congruent to JO? Yes, we can. Or we can do a separate reflexive step. Honestly, it's whatever occurs to you at the moment. Okay, just realize if you put all of those together in one step, we are going to get two sides in step 3 here. So in step 3, I'm going to say that GO is congruent to HO, is congruent to JO, and my reason is all radii are congruent. I've got my 3 congruences, which means I'm ready to say the 2 triangles are congruent. So I can say that triangle GOJ is congruent to triangle HOJ, and it's because all 3 pairs sides are congruent. And then finally, I can say that angle G is congruent to angle H. Why? Because they are corresponding parts of congruent triangles, therefore they are congruent. CPCTC. So as I mentioned, when it comes to step 3 there, if you saw that JO is also a radius, you can include it in step 3, or you can have a step 4 where you say JO is congruent to itself reflexive. Okay, both work. And so there you have it. That's CPCTC and circles and proofs. So remember, CPCTC stands for corresponding parts of congruent triangles are congruent, and it can be used after you have proven two triangles are congruent. And then a new theorem for us to use in our proofs, if we're given a circle, we can say that all radii are congruent. So I can use that given piece of information to say OA is congruent to OB. And that's how Backer breaks it down.